she wants a tall light to illuminate the 3 entrances. Where are the entrances located? Where are the entrances of this parking lot? Which are located at ABC. So this is one entrance, this is another entrance, and this is the 3rd entrance. She wants to position the lamp so that it illuminates each entrance equally. So the lamp has to be in the center of the 3 entrances, right? What shape do the 3 entrances form if I were to connect the points? 1, 2, 3. Okay, we need to find the center. I'm just going to draw a little dot there. We need to figure out where the center of this triangle is. Does anyone know what the center of a triangle is referred to as? Okay, the center of a triangle where all the points meet is called the circumcenter. Okay, but what meets in the center of the triangle? It's the center of the triangle. It's the same distance from all 3 vertices. And it's actually where all perpendicular bisectors meet. Okay, so what we need to find is the perpendicular bisectors of this triangle, and we have to figure out where they all meet. So we know that a perpendicular bisector is a line, right? We need to find the equation of the line. It's a line that bisects another segment. What does bisect mean? Cut in half. So let's start with this one. It bisects a line, but it runs perpendicular to it. Okay, so we need to find the equation for a perpendicular line that is perpendicular to AB. We need to find one that bisects BC and runs perpendicular to BC. And we need to find one that is perpendicular to AC and is, okay? So to figure out the perpendicular bisector of AB, what's the first thing I need to find? Yes, I need to know the midpoint. It bisects in the middle, right? So we need to find the midpoint of AB. Midpoint of AB, let's call this x1, y1. So -1 plus x2, y2 plus -4 divided by what? How do you find midpoint? Divide by 2, and then we have our y coordinates, 14 plus 8 divided by 2. What are the coordinates of the midpoint? Good. So the midpoint is located at -6, 11. I need to know the equation of this line. I know one point on the line, and I know that it runs perpendicular to AB. What does that tell us about the slope of the perpendicular line? What's it going to have? The slope has to be negative reciprocal of AB. So let's find the slope of AB. y2 minus y1. 8 minus 14 over x2 minus x1. -4 minus -8. What is the slope of AB? In lowest terms, we get -3 over 2. Okay, that's the slope of AB. What is the slope of this perpendicular bisector that goes through AB? What's the slope going to be then? Negative reciprocal. Yes, Sylvia? Positive 2 over 3. So right now, we know that the slope of the blue line is 2 over 3, and we know a coordinate of the blue line. That point, the midpoint, is on the blue line. Can you find the equation of the line now? We're trying to find the equation of the perpendicular bisector. The slope of the perpendicular bisector is what? 2 over 3. And we know a point on the perpendicular bisector is -6, and it's located at -6, 11. So our x is -6, y is 11. I'm just going to make these fractions. Solve for b. 11 over 1 equals, what's 2 times -6? 3 times 1. What's -12 divided by 3? -4. What's b equal to? 15. What is the equation of that blue line going to be? Good. Y equals 2 over 3x plus 15. I'm replacing my B and I'm replacing my M. That's the equation of the first perpendicular bisector we had to find. Okay, so we just found the equation of the blue line. We have to find the equation of the pink line and the orange line because we need to find out at what point do those lines intersect. Now we're going to follow the exact same steps to find the equation of the perpendicular bisector that goes through BC. So again, we need to find the midpoint of BC first. Yep, okay, midpoint of BC is 7, 9. What's the next step? Slope, good. Slope of what? Slope of BC, good. So the slope of BC is 1 over 11. Therefore, the slope of the perpendicular bisector will have a slope of negative 1 over 11. You have a coordinate. What are we solving for to get the equation? Okay, we need to solve for B so that we can write our equation of the line. Okay, so when you plug it in, you should get B equal to 86. Therefore, the equation of the pink perpendicular bisector, replace M and B, and you get the equation. So back to the original question, we need to position the lamp so it illuminates each entrance equally. Well, we need to know, again, what's that point called? The center of the triangle? Circumcenter, which in this case is the point of intersection of the perpendicular bisectors. So we need to know where do these two lines intersect. Okay, so we can find where they intersect by substitution. So y equals, we're using the two equations, negative 11 x plus 86. Let's replace that y value for this equation. And what are we solving for? What are we solving for now that I've replaced y? I plugged in y into the first equation, and we're solving for x. So start by finding a common denominator, because you know you're going to be grouping like terms. Negative 11 times 3, negative 33 over 3x. What do I want to do with this? Bring it over, becomes subtract, and I have my positive 15 on the right side. What do I do with the positive 86? When I simplified both sides, I have negative 35x divided by 3. What's the opposite of divided by 3? So to get rid of that divided by 3, I multiply. I'm left with negative 35x equals negative 213. Isolate your variable, divide both sides by negative 35. X is approximately equal to 6.09. So you found x. Now we need to know what y is equal to. I'm going to work with the second equation and plug in my value of x, which we just found is 6.09. Plug it in, solve for y. Yeah, approximately 19. So the point where the perpendicular bisectors intersect, we're going to round it off. It's approximately located at 6:19, which means that if the lamp is placed at this point, it's going to be the same distance from each entrance, which means it's going to illuminate it equally.
Made with Doodlecast Pro.